Welcome, ladies and gentlemen, to the George Blaney podcast. Is there a large, undiscovered planet lurking in the shadows of our outer solar system? In a paper titled Evidence for a Distant Giant Planet in the Solar System, published in 2016, Konstantin Batygin and Michael E. Brown argued that the abnormal clustering of orbits among the trans-Neptunian objects can only be explained by a large, unseen planet hurting their orbits. Now, what are the chances that such a planet does exist? And what can anyone know about a planet that has never been observed? Batygin and Brown must have known well that this would by no means be the first time that such a planet had been theorized. In 1846, the French mathematician Urbain Le Verrier successfully predicted the location of Neptune in the sky to within 1 degree, simply from abnormalities in Uranus's orbit. Neptune was then discovered at the Berlin Observatory in 1846. Unfortunately for us, Neptune was not the only planet thought to exist inside of our solar system, in addition to the other planets. That same man who accurately told German astronomers where to find Neptune in 1846 also theorized the existence of a planet called Vulcan. Such a planet, he theorized, would explain peculiarities in Mercury's orbit. However, after Einstein's theory of relativity had been published in 1915, it became clear that there was no anomaly there. Astronomers are extremely confident today that no such planet exists. Furthermore, following up upon the same logic that led to the discovery of Neptune, Percival Lowell in 1906 theorized the famous Planet X, thought to be orbiting beyond Neptune. Although Pluto was hailed and is often credited as the planet in question, Planet X never existed either. The mass of the Pluto system is far too small to account for what Lowell thought he saw, and furthermore, as better data has come to light, particularly after the Voyager 2 flyby of Neptune in 1989, it's become clear that Lowell actually had a slight overestimation of Neptune's mass, and again, the anomalies in Neptune's orbit never actually existed. In short, Planet 9 would not be the first time that astronomers had theorized an additional large planet in the solar system to exist in addition to all the other planets. In most of the cases historically where scientists have theorized such planets, it has come about only because of an incomplete understanding of planetary orbits or because of faulty or inaccurate data. So, what makes these guys think that this time they're right? Well, first off, there are many things that we can definitely say that this isn't, rather than what this is. So, for example, could it be that no such anomaly actually exists, and that astronomers are not actually seeing anything out of the ordinary? For example, perhaps all the astronomers that found the TNOs in question only looked in a particular part of the sky, and thus biased whatever objects that they were likely to discover. This would be the most obvious solution to our problem because, many of the telescopes are located on Earth and only have certain portions of the sky available for observation. And furthermore, astronomers consciously looking for TNOs, trans-Neptunian objects, often look towards or near the plane of the solar system, and not perpendicular to it, for example. Objects like Sedna and other objects with really big, high eccentricity orbits are biased by themselves on being much, much more likely to be found or spotted when their orbit passes closest to the Sun during perihelion. However, the most distant objects considered in Batygin and Brown's analysis, including Sedna, for example, were all discovered individually on 6 different telescopes and on 6 different sky surveys. In their paper from 2016, they cite the unusual movement of objects crossing the plane of the solar system from the south to the north of the ecliptic as unexplainable due to any observation bias. But so what, right? So a few trans-Neptunian objects orbit a little funny. Does that really require an external explanation? Well, Battigan and Brown demonstrated in their paper that random orbits would only produce such unusual clusterings of perihelion positions and orbital planes 0.007% of the time from chance alone. If they were right, that would mean that although this could be nothing, it could be pure chance, the odds of that are extremely low. Okay, so something's up. But how do we know that this is part of a giant planet? This is because of a giant planet, right? Perhaps something else is going on. Gas giants are known to have dramatic effects over the objects inhabiting their realms. Perhaps Neptune is to blame. It is known already that many objects, including Pluto, have orbits that have been harmonized with Neptune. For example, for every 2 Pluto orbits, Neptune orbits the Sun exactly 3 times. Maybe something similar is going on. Nope. Unfortunately, this fails to explain observations. Let's suppose instead a star made a close encounter with the solar system long, long ago and skewed many of the orbits in the outer solar system, these trans-Neptunian objects. Well, again, this explanation fails under closer inspection. Each of the objects that we have observed should have their orbits precessing at different rates, right? So this means that unless the star had passed extremely recently, which isn't possible, such alignments would be unstable, and the clustering of positions would have long since disappeared. So, okay, we can't really explain what's going on, but how does an extra planet help us here? How does it solve these problems? Well, computer simulations show how a large planet could reorganize the orbits of trans-Neptunian objects. The clustering orbits in the context of a large planet could provide protection and prevent their orbits from being destabilized. The theorized high inclination to the plane of the solar system of Planet 9's orbit might explain the unpredictable variations of these semi-major axes among the trans-Neptunian objects. Such a planet would cause objects to jump between resonances and may explain extreme variability observed in objects like Sedna that have extreme eccentricities. In fact, Planet 9, if it exists, would explain 4 peculiarities of the outer solar system. Number 1, the clustering of trans-Neptunian perihelia, or in other words, the point at which these objects are closest to the Sun seems to be clustered together. The similar inclinations of these objects, so again, these objects seem to be inclined to the plane of the solar system in the same direction. The high eccentricity of these orbits, so it would explain orbits like Sedna, for example, and nearly perpendicular inclinations of some trans-Neptunian objects. Now, these are slightly different, but there do seem to be an interesting number of objects in the solar system which seem to be completely perpendicular to the planetary plane. So, if Planet 9 does exist, it raises its own set of questions, like where did it come from? Well, as you might expect, there are several theories. It could have been captured from another star, from another solar system by our sun. Battigan and Brown believe that Planet 9 originally formed much closer to the Sun and was ejected into the outer solar system. Planet 9's mass, from what the models tell us, should be somewhere between 5 and 10 Earth masses. So perhaps this planet was destined to become a gas giant, but whose growth was halted when it migrated into the outer solar system. Now, what are the chances of us actually finding Planet 9, of spotting it through a telescope? Well, much of the sky in question, where it needs to be, has been covered by telescopic surveys, and many positions on its theorized orbit can already be ruled out. But if Planet 9 was close to aphelion, for example, it was, for example, at the farthest point on its orbit away from the sun, it's very likely then that it would be too dim to have been detected by previous surveys. Furthermore, surveys conducted which happen to be near the band of the Milky Way are often hampered by the abundance of stars, making detection difficult. So, does Planet 9 really exist? And will proof be found within our lifetimes? Well, I, for one, don't know, but I am very excited to hopefully find out one day. Thank you.